Hi, we are Juan, Fernando, Eduardo, and Ariel. We're going to talk about the last practice of the laboratory. In the first segment, we have the SA0, that is the beginning sensor that it's going to connect with the timer. The timer has a PT with 4 seconds. That's going to go with J1, who is extended the cylinder.
Okay, so then we have the segment number two where we are going to define a latching circuit. The latching variable is going to be the white tree, and here we will have some other variables like SA1. That means that the first cylinder is extended. Also, we have SB0. That means that is the signal that will control the retraction of the cylinder. Also, we will have the memory, a variable for the memory in order to have the 3 cycles. And we have SB1 that is going to be the variable that will represent the extended movement of the second cylinder. And as I told you previously, we will have a Y3 that is the latching variable that also will have other implications in the full diagram.
So then in segment 3, we verify the position of piston 2. And in this case, we check that the piston retract and extend 3 times. So if this happens, we activate the start sensor of the first piston again, which will indicate that it is time to reset it. And this reset allows us to go now to the value in the memory variable.
Okay, in segment 4 and 5, we control both cylinders retraction action. We use in segment 4 the sensor B1, that's when the cylinder is extended. We sense when it's extended. And we have a normally closed SB0, so that when it retracts, it no longer sends the action J4. That's the B cylinder retracting. In segment 5, we have SA1, the memory, SA0, and G2. SA1 is the sensor of the cylinder when it's extended. The memory is the value that the counter gives us. SA0 is the sensor when the cylinder is retracted. And J2 controls the retraction of the cylinder.
For this practice, it was a little difficult at first, the software, because it was new to me, but then I realized how to use it. Then it was really easy to make the practice. In this practice helped me to understand which is the operation that require processes with a specific timer. For this, I had to learn the logic of this and to make it work properly with electronic components that help the proper functioning of this. Likewise, both cylinders must be properly sensed at the same time, otherwise the whole circuit that was set up for the operation of this one will not work. This was a interesting practice. Also, because we knew how to use the laboratory without stay in the laboratory because of the pandemic.
For this practice, we had some problems due to the fact that personally I've never worked with and configure a PLC remotely. So, however, the support video that the teacher provided us solved all our doubts. And once it was able to connect correctly to the PLC, the programming was so similar to what we did in Fluid Sim. Um, what I liked the most in this practice was the fact that not only did we simulate the systems, but we were also able to see the real operation of the system through a camera.
We learned that we can program and control the labs on the campus remotely. And at first, we started having a lot of issues connecting to the PLC and achieving the connection with the camera. But once we had that figured out, finding the logic and all we had to do to get the system to work, it was pretty straightforward. We only had the timer that started this process and a counter that depended on the state of the first cylinder to extend and retract. And overall, I think it's really easy to program PLCs, and it's a technology that allows us to get some really good industrial processes.
Also, it's important to say that as a conclusion, the development of this practice was really good for us in order to learn and also understand that we may use a memory in some circuits in order to have a better response on and have the behavior that we want of the full system. Also, it's important to say that by using the latching circuits, we almost can control everything, or it's a good way to control and have the what we want to do with the circuit. And I think it was a really good exercise in order to connect to to a real PLC and know how it could be in the real world.